little note about the word polynomial. I find it fascinating. This is Mrs. Vogt. You can think I'm a dork if you want to, but the word poly is a Greek word meaning many, and the nomial part is a Latin word meaning name. We have many terms is what polynomial kind of boils down to. So polynomials have many terms. And it says the Latin root bi, like bicycle. Well, we reserve that term binomial for items with two terms only. And so polynomial is kind of like the umbrella for all the different names we have for specific polynomials. So things that are polynomials, you can see on the left look like this, not polynomials on the right here. So I hope that you notice this here and this here. So polynomials don't have negative exponents at all. And polynomials, I'm going to switch my screen, sorry guys. Polynomials don't have exponents in the denominator. They do have positive exponents. And so you'll see here, these are all exponents. We know what those are. This exponent is technically x to the 1. And if I was being super technical, this would be x to the 0. So we are going to continue just talking. This is a lot of lots of definitions today, so make sure that you're pausing. I know it's going to be a long video, but that's because we kind of have a lot of background information to set up. So we need to talk about degree and leading coefficient. And I feel like these two things kind of work hand in hand, and they're difficult to separate, at least for me. So degree is the highest exponent. So if you're looking at this example I have done here, 4x squared, 3x to the 7 minus 45, this is a 7th degree polynomial. Okay, so the highest exponent. Leading coefficient is the number, or the coefficient, in front of the term with the highest exponent, biggest exponent, whatever you want to call it. So we already said it was 3x to the 7th, so the leading coefficient in this one is 3 is our leading coefficient. And you'll see me abbreviate it LC. So then I wrote in a little note over here, standard form. Standard form is what we like to call putting the like these terms, the terms in order from the biggest exponent to the smallest. So this one will go 3x to the 7th plus 4x squared minus 45. Now, if you put something in standard form, which is the way we kind of like to see it, it has order to us, right? It goes from biggest to smallest. It's super easy then to see that this is a 7th degree polynomial, because we can easily see the biggest exponent, and then the leading coefficient is 3. So putting things in standard form, you should always check that first to make sure that you're getting the right leading coefficient and the right exponent for determining what the degree is. So degree and leading coefficient and standard form are all important vocabulary words here. And I meant to go back and change this, but I didn't. Anyway, this should say x-intercepts. So zeros technically have 3 names, which is, not confusing at all, right? Zeros, x-intercepts, and roots are all the same, mean the same thing. So what does it look like on a graph? Well, you guys know what an x-intercept is. It's right here on a graph. Okay, so this has 2 zeros. Or you could call them roots. Or you could call them x-intercepts. Okay, so there are 2 on this one, and hopefully by the end of this lesson you'll be able to tell me that this is a 2nd degree polynomial. We call that a quadratic, and it has a negative leading coefficient. Now, I didn't use magic to determine that, even though I did graph this myself. But there are some patterns and some rules that all polynomials follow that makes it pretty easy for you to be able to tell by looking at them. So that will be coming up next. And how do you tell using math? So before we get too far, I want to talk about how we know something is a factor. So if I told you, is 3 a factor of 12? And is 3 a factor of 14? And you would tell me like, well, if I divided these, 3 times 4 is 12, and I have a remainder of 0. And if I did this over here, 3 goes into 14 4 times. Oh, and I have some left over, so I have a remainder of 2. So when I'm looking at this idea, 3 times 4, no remainder, 3 is a factor. But is 3 a factor of 14? No, because it has a remainder. So why would I make you look at that again? Because it's similar here in polynomials. Okay, if I plug in this number 4, I'm saying is 4 is 0, and I get the answer 0, then it's a 0. Okay, I use the word factor, but it's a 0. And we'll talk about factors and zeros actually in the next video that we do. But this idea is really similar, that when there's no remainder, then I know that it does work. It is a factor. So I'm going to plug it in. And every place I see an x, I'm going to put a parenthesis. And I'm not doing that to be extra. I'm doing that because in your calculator, if you type this and you type this, you get 2 different answers. Okay, this is the right answer. This one here is telling the calculator to do 2 squared and then multiply it by -1. So you need to be 1 smarter than your calculator. And putting negative numbers, putting any of these numbers here in parentheses makes you 1 smarter than your calculator. So 4 to the 3rd, and go ahead and get out your calculator. Okay, 4 times 4 times 4, 64, minus 6 times 16, plus 40, minus 8, and 16 times 6 is 96, so I have 64 minus 96 plus 40 minus 8. And you're going to type that into your calculator or do it in your head, I don't really care. And you get the answer of 0. So is 4 a 0? Yes, 4 is a 0. There's no remainder. There's no answer left. The answer is 0. So that's good. So if I ask you, can you tell if this is a 0? You plug it in. If you get 0, surprise, it's a 0. If you get a number that's not 0, then it is not a 0. So here's where I told you that we would be looking at graphs, and I've seen these like little things, math dances, and I pulled out this guy who demonstrates a few of the ones that we're going to look at today. And I really want to I want you to separate these by odd and even, because we have, and then I'm going to even do this. I'm going to separate these by positive leading coefficient and negative leading coefficient. So when you are odd, like this guy, x to the 1, and it's positive, you move up into the right and down into the left. Okay? And I'm going to give myself a few different axes here. You should do the same here. So these are just sketches. So sometimes your homework says sketch. Okay, sketch means a rough picture, because you guys already know what an artist I am. Okay, so this is x to the 1 with a positive leading coefficient. So the next odd one I'm going to do is x cubed. So I want you to, okay, again though, at the ends it's down into the left and up into the right. And how about x, oops, not to the 4th. So that's not odd, x to the 5th. Okay, there's more squiggles in the middle of this one. I could even go x to the 7th, maybe. So I hope you notice that when the leading coefficient is positive and you have an odd degree, you guys know what odd numbers are, 1, 3, 5, 7, 9, x to the 99th, for example. The left side will point down into the left, and the right side will point up into the right. So what happens, and it looks like this guy, right? So this is and this guy. You can see his little hand moving up to the right and down to the left, okay? If it's a negative leading coefficient, it goes the other way. Left hand high, right hand low. So x to the 1, x to the 3, x to the 5. I can even do x to the 7th. Okay, so being able to look at these, and then how do you tell? I go like this, like 1, 2, 3, 4, 5, 6, 7. Okay, or like you can count the zeros. Look at 1, 2, 3. Now that's not a foolproof way, but just thinking about these in terms of how many times could it cross. Okay, I'm going to use a different color for my evens, and maybe not going to do quite so many. All right, so now I've got even, okay, x squared. So x squared looks like a smile. Okay, x to the 4th kind of looks like a W. X to the 6th. Okay, hopefully you notice that in these, both hands point to the top. Okay, they go, even arrows go in the same direction. When it's a negative leading coefficient here, like this one, we have a frown, an M, and something like that. Okay, so being able to tell what a picture looks like based, or what the degree is and what the leading coefficient is based off the picture. Okay, so hopefully that little guy helps remind you. So why is this important? It's important because the mathiest thing probably you've seen all year, it's called the fundamental theorem of algebra. So it says that the number of complex solutions to a polynomial function, remember complex means real and imaginary, okay, is equal to the degree of the polynomial function. Okay, knowing this gives you a good starting point when you're required to find the factors. Well, okay, what does that mean? Again, I'm going to separate this into even and odd, because they still follow some interesting patterns. Odd functions always have one real no matter what. So what do you mean, Miss Vogt? Well, there's no way for me to go from low to high without crossing at least once. So like this one has 1 here. This one has 3. Well, that's good because this is x to the 1, x to the 3 here. Okay, but it also means that if I drew another picture of x cubed, I could draw it like this. And I would be able to look at this and say this only has one real root. But I also know that this is supposed to be an x cubed function. And the fundamental theorem of algebra says if it's an x cubed function, it has 3 roots. So I have 1. What about the other 2? Well, those other 2 are imaginary. Okay, so notice 1 plus 2 equals 3. This is an x cubed function. Okay, so another, let me see. If I drew one more over here, I could draw, well, this is an x to the 5th function, so I have to have 5 roots. But how many do I see? 1, 2, 3. This has 3 real, so it has 2 imaginary because I need to get to 5 total. Okay, so it's really important for us to know those shapes. So what about even? All right, well, even, so I could have, I'm going to write x squared here. X squared could look like this. It could look like this, and it could look like this. So the interesting thing about evens is that they don't always have to have one real, like I said over here. Like, remember I said odds always have one real? Evens can have 0 real. They can. That doesn't mean they always do, but they can. Okay? So, for example, these are all x squareds. This one has 2 imaginary because it never, ever crosses. Okay? This one has 1 real. This one has 2 real. Okay? So I need you to be able to look at a picture. Any picture I give you, and wherever it crosses the x-axis, where you can pick up your pen or pencil or finger and touch the x-axis, that is a real 0 that belongs to that function. But you need to be able to get all the way up to the degree. And when you have extras, zeros that I can't touch, those are imaginary zeros, and you need to account for those too. Okay? So that's why the fundamental theorem is really important. Now, I think we've done everything. We identified the degree and leading coefficient. We did the graphs by shape and zeros from the graphs. So I think we've got everything. But again, this was super duper heavy. So make sure that you paused and took a lot of